Just want to say good morning to everyone. My name is Matt Klassen. I'm the Executive Director of TMA BlueTech. Thank you very much for joining today's webinar. The topic is a bright blue future, environmental services and pinpointing solutions. We were meant to have 3 presenters today, but unfortunately one of them, Luca Gambarini with Nemo's Garden, has had computer issues over in Italy, so he cannot join. But we do have Dennis Calvert with BioLargo here, and Randy Lynn with Biospherical, and we are very much looking forward to their presentations. Before we get to those presentations, a little bit about TMA BlueTech. TMA was founded about 14 years ago and is one of the largest and most reputable BlueTech cluster organizations in the US and in fact the world. We're a nonprofit industry association and cluster organizer for the San Diego Ocean and Water Technologies community. And our tagline is promoting blue tech and blue jobs. We bring education, policy, and technology resources together to promote innovation and economic development in the blue economy. We create a strong blue voice via unique events like this one, information sharing, national and international outreach, networking, research, and workforce development. So with that as a prelude, I wanted to go over a little bit of housekeeping. The presenters initially had 8 to 10 minutes to present, but that was for 3 presenters. We've got 2 today, so we can take it a little more easy with the time. You guys can take a little bit longer if you need to, but this also opens us up to a longer Q&A session towards the end. If you do want to ask a question, kindly put it into your chat box, and we will present the question to the presenters here today during the Q&A session. And if you would kindly turn off your microphone throughout the duration of the presentations, or at least until follow-up Q&A, that would be fantastic. So with that, I would like to turn it over to our first presenter, which is going to be Randy with Biospherical. Randy, over to you.
Good morning, and thank you, Matt, and thank you, Danielle. I'm going to try to share my screen here so I can get into the presentation. I think we worked through this before, so hopefully it will work. Let's see, and share. Did that work for everyone?
It has, yes.
Okay, great, excellent. So yes, as Matt mentioned, my name is Randy Lind. I'm president of Biospherical Instruments, and we design and manufacture optical instruments for environmental monitoring. At the bottom of that slide, you can see some of our customers over the years. And so we've had a lot of domestic and global work. Let's see. Oh, there we go. A brief overview of our company. We were founded in 1977 in San Diego, California by Rocky Booth. And Rocky is the gentleman in the green sweatshirt to the right of Jacques Cousteau. And Jacques Cousteau was one of Rocky's early collaborators on scientific projects. We design and manufacture scientific instrumentation for environmental monitoring and research and development. This consists mostly of sensors and systems that measure light in the oceans, on land, and from airborne platforms. We also possess a world-class radiometric calibration facility, which is traceable to NIST. We can perform a number of optical characterizations as well as calibrations. Our customers include systems integrators in industry, as well as researchers in government and university laboratories worldwide. And we truly are a global operation, and we've had deployments to Japan, France, Norway, throughout the United States, Puerto Rico, Argentina, Antarctica, and the Arctic, including 4 expeditions with Jacques Cousteau. Some of our company milestones. We were incorporated in 1977, and we began selling coral reef PAR data loggers. PAR is photosynthetically active radiation, and that is the portion of the solar spectrum that phytoplankton and other plants use to create energy. In 1978, we introduced the QSL laboratory PAR sensor, And that is still in use today, and we still have some of those units that come through for calibration and service. In the late 70s and through the 80s, we received significant funding from Japanese fisheries departments and NASA, and participated in multiple Cousteau cruises. In 1987, the National Science Foundation commissioned us for ozone hole impact research in Antarctica. And that became a multi-decade project where we installed, maintained, and processed data for the UV monitoring instruments in the polar regions. That led us to release our own instrument, the GUV, or ground-based UV radiometer, developed specifically for UV monitoring networks. And there's multiple networks still existing, and we have updated instruments that are going into those networks to sort of keep them going as we move forward with technology. In 1990, we introduced instruments for measuring UV in the oceans, and in 1992, we went on a Cousteau expedition studying coral reef bleaching. In 1994, we moved into our new building, still in San Diego, where we have an observation deck with a clear view of the sky, and we have upgraded calibration facilities. In 2004, we received NASA SBIR funding, and that allowed us to develop the Microradiometer for ocean color research. And the Microradiometer has become the core architectural building block of all of our modern instrument systems. In 2008, the Microradiometer was ready for prime time. And so we released our COPS line of instruments. And they've been deployed throughout the oceans and lakes globally. You can see in these photos, in one instance, it's being deployed along the ice shelf edge. And in another photo, they've actually drilled a hole in the ice sheet and are deploying it under the ice shelf. In 2011, Biospherical provided the lead author for the NOAA State of the Climate Report for UV and for the UV and ozone chapter. And that's a responsibility that we hold to this day. We have an atmospheric physicist on our staff, Dr. Germar Bernhard, and he participates in that every year, as well as other scientific panels. In 2011, we released sea air radiometers, and that was again microradiometer based, and that extended to NASA flight operations for ocean color remote sensing. In 2014, we released an updated version of our GUV instrument, which extended the spectral range from the near IR, or from the UV all the way out through the near IR. And that, of course, as you can imagine, was also microradiometer based. In 2019, we released the XRR radiometer, and that was a lower cost version of the COPS system built on microradiometers. And in 2020, we've released the MPE. It's a PAR sensor suitable for very low light level operations targeted at bioargo floats and gliders. And the core of it at its heart is a microradiometer. And in late 2021, we were acquired by AdaptaSense, and that presents new growth opportunities for our company. So why do we do this? And why is light important? This is a question that we get asked all the time. Sunlight is a critical input to both the marine food web and the carbon cycle, and scientists need to measure this input. Additionally, microscopic primary producers, phytoplankton, and primary consumers, zooplankton, impact, oh, sorry about that. Skipped ahead. Impact the amount and spectrum of light that penetrates the water. That is to say, they change the color of the water. Similarly, dissolved organic and inorganic material changes the color and clarity of water. So that all comes together to say that the color of water can be used to make in situ estimates of the concentration of chlorophyll and other constituents. The graphic on the left shows sun as the input into the ocean, and in the euphotic zone, which is the top layers of the ocean, the phytoplankton and zooplankton. The right-hand side of that graphic shows floats and gliders. And that's a target market for us because those floats and gliders can contain irradiant sensors that measure the light in the ocean. They can measure the PAR, the photosynthetically active radiation, and they can also make multispectral or hyperspectral measurements. And it's through those measurements that we can infer the concentration of chlorophyll and other constituents. The images on the right show phytoplankton and zooplankton. And so you can imagine how those microscopic organisms at great quantities can dramatically impact the color and clarity of water. So what are the markets for our instrumentation? On the science side, we've done a lot of work in the calibration, validation, and research areas. Calibration is when our instruments are used to vicariously calibrate ocean color satellites. So when NASA or another agency launches an ocean color satellite into space, they can never get it back to the calibration lab for recalibration. So they need to use Earth-based instruments to provide what's known as sea truth data in order to recalibrate the satellite sensors. On the validation side, it's when our instruments are used to confirm the operation of new instrument systems or technologies, or to confirm the outputs of new algorithms to derive data products. And on the research side, it's an all-encompassing area that deals with general scientific inquiries. The lower image there shows a global map showing chlorophyll estimations made from space. And that's the kind of application where our instruments help the satellite sensors stay calibrated. The right-hand graphic shows another one of our target markets, which is oceanic and terrestrial observing networks, such as the Argo network, gliders, moorings, and UV monitoring. The image there shows the February 2022 population of biogeochemical Argo floats. Argo are profiling floats, and you can see there's a global distribution of them. There's actually more than that don't have the biogeochemical sensors, but our target market is the biogeochemical sensor ones because they specify irradiance, which is a measurement that we make with all of our instruments, as one of their parameters. So you can see there's 450 operational floats, and there's 16 countries that are deploying those floats. So more market opportunities. We find opportunities within industries of fisheries, aquaculture, and defense, as well as education and citizen science. Our instruments are used to monitor and research healthy oceans, for bioluminescence, which has biological applications as well as defense applications. We can detect and monitor red tides that has significant impact in fisheries departments. In harmful algal blooms, which are often caused by excess nutrients running off from agricultural operations, our instruments can provide early detection for the changes in water color that would let people know that there's a harmful algal bloom about to occur. Our instruments are used for atmospheric research and also find applications with fish farms and aquaculture. So what are the challenges that we face now and have faced traditionally? One of the challenges that we've dealt with is consensus, both scientific and in terms of technical integration.
It's just a small area.
On the scientific side of consensus, what we found is that a group of scientists will rarely agree upon the correct way to compute a data product or even how to treat a data set. So it's made a challenge for us to design software that will satisfy the entire community. And so it makes us have to decide, do we just provide raw data, or how deep do we get into the data processing side of things? On the technical integration challenge side, one of the issues is that with large networks in particular, such as Argo, there's a number of manufacturers, and each manufacturer may have a slightly different power supply requirement or a communications requirement, and they all have different firmware sets. So there's no universal standard that allows us to plug into these networks. And that's a technical challenge that we're working to address, unfortunately, mostly on a case-by-case basis. Another challenge that we have faced is production efficiency and volume. Our traditional work has been low volume and high value. And we've attempted in the last decade to address the efficiency side of that with the development of the microradiometer. And that's provided a common architecture that we can use across our instrument lines. But that being said, we're always looking for higher absolute volume markets, and that's where we can drive further efficiency. Another challenge is finding specific industrial applications with integrated actionable data. So it's one thing for a scientist to use our instruments and examine a water mass and learn something interesting about it. It's another thing for our instruments to provide process control inputs. We've had some success with this in the past with drinking water reservoirs, where our instruments were installed to provide early detection for an algal bloom. And that allowed process control inputs to decide when and how much to treat with disinfectant agents. So where do we see opportunities? We see a great opportunity in synergy with our new partners in the AdaptiveSense group to improve our design efficiency and time to market. On the lower left image there, we have a partner company now, Bro Research Organization, and they bring advanced optical design software to the table. Another AdaptiveSense partner, AUV Flight Services, provides airborne platform expertise, including integration and piloting. So in the past, we would either have to go out of house at expense for this, or we'd try to take on these tasks in-house with limited resources, or we would have to pass on opportunities. And so being partnered with a greater group provides a wonderful opportunity for us to not have to do it all ourselves. We also see opportunity in collaboration with alliances and technology clusters. The TMA BlueTech is a great example of this. And additionally, Bro Research Organization, one of our partner companies, was a founding member of an Arizona optical cluster, and they had great success through the cluster model. We see opportunities with new markets, new system integrations, hyperspectral, and PMT-based hybrids. PMT is a photomultiplier tube, and that allows for very low light level measurements. And we also see opportunities with autonomous airborne operations, and that again relies on our new partnerships. So I was gonna wrap the presentation up there, but with a little extra time, I'll dive a bit more into the microradiometers, since that is a core theme throughout our instrument line. So the microradiometers, it's a new technology for measuring light. And this was done under the NASA SBIR development. What's unique about it, it's a fully contained radiometer on a single circuit board. It has a filter assembly, a photodetector, multi-stage amplifier, and a 24-bit ADC, as well as a microprocessor. Its performance includes an auto-ranging acquisition system, and it has dynamic range approaching 10 orders of magnitude. We can cluster up to 19 channels in an instrument, and the spectral range goes from 305 to 1640 nanometers, and we can sample at rates of up to 18 hertz. So why is the dynamic range important? When you're measuring light, both in the atmosphere, but in particular in the ocean, the dynamic range of light that you encounter is huge. For comparison, if you're measuring temperature in the ocean, you will get readings from, say, -2C or so up to 35C, maybe if it's really hot. So it's less than 2 orders of magnitude. Well, the light varies substantially more than that, and the microradiometer can measure up to 10 orders of magnitude in dynamic range. This time plot that we show here shows a microradiometer being pointed at the sky in San Diego. And on the left-hand side of the plot, you can see where we're measuring the moon at its highest point in the sky. On the very left-hand side, you can see if you cap the sensor and measure true dark, there's still approximately 3 orders of magnitude of dynamic range left to measure. And the other interesting thing is that as the moon sets, we still have measurable signal, and it can go all the way to measuring direct sun during the day without saturating. Most legacy sensors would have to be tuned specifically to measure either bright light or dim light. And so with the microradiometer and its adaptive ranging, it's kind of like having a microscope and a telescope in a single instrument. And the microradiometer-based products that I mentioned previously are shown here. And you can see that we've really exploited this development and tried to use it in every conceivable product because it's our highest end acquisition system and its form factor makes it very adaptable to new designs. And of interest, some of the new opportunities that I mentioned that I didn't touch on in the timeline were in the left-hand side here, we have an instrument called low lux, where a microradiometer is paired with a PMT, photomultiplier tube, and that extends the dynamic range to almost 14 orders of magnitude. And we also have instruments, the towfish and these harpoons instruments here. This is where microradiometers have been paired with spectrographs for hyperspectral measurements. And many of the new ocean color satellites are hyperspectral in nature, but hyperspectral measurements suffer from a low signal to noise ratio, and they have limited dynamic range. And so we are trying to combine the best of both worlds in order to satisfy the scientific community. And so that's sort of an overview of what we do and how we got to where we are. That's 45 years of history in 10 to 15 minutes. And I thank you for your time, and I hope you found it interesting.
Thank you, Randy. I know I have some questions on my end as soon as we get to the Q&A part, but that was really, really interesting. So particularly, I think about it before we get to the Q&A session, but some particular stories you may have about how your technology has been deployed, things you've discovered. We'll get to that in a bit, but just think of some stories you can tell about what your technology has led to.
Okay,
very
great.
Good. Thank you very much.
Uh-huh.
And now we have Dennis Calvert with BioLargo. Dennis, are you there?
Hey man, I'm here, ready to roll.
Welcome, welcome. The floor is yours.
All right, thanks. Here we go. Thanks everyone. It is my pleasure to be here. Let's see here. Here we go. Perfect. So thanks for the audience and the time. Appreciate your attention. I'm going to cover briefly some of the technology features. We can dig deep into that in the Q&A if you're interested. I think our story is so interesting. You know, we've been developing technologies now for about 15 years, and we have a portfolio approach. Quite challenging, extraordinarily exciting. And we have a number of principles we'd love to share with you about our journey. I think the lessons we've learned, why we have experienced some success, why success is expanding, and some of the things we think are critical for success. And we hope that's helpful for you. So at BioLargo, everything we do is really focused on making a high impact. We make life better. You know, when I go out and do presentations at Wall Street, people look at me and they go, wow, you know, quite a vision, right? And I say, yeah, it is quite a vision. You know, everything we're focused on is a sustainable solution. And as we say, air, water, and earth. So it is a diversified portfolio. We have at least 7 distinct technologies. Some have been acquired, some have been grown organically internally. We are also a small public company, which has presented itself challenges as well as some really great features, tools that we can use to grow our business. We'll talk about that briefly. In the portfolio, as we said, air, water, and earth, air, water, and earth. And we also have a medical company, and the medical company is really positioned for a spin out. Entered into a license, we did the incubation work there, and did some of the hardest work, which we'll talk about, in order to position some of that technology to find its way into the commercial market and journey through an incredibly difficult regulatory barrier and highly competitive. In the environmental portfolio, we have an engineering group, we have a water company, and we have an environmental services company with a key asset is focused on air quality, odor, and VOC control. And they are very much intertwined, right? As you can imagine, different talent sets working together where one picks up, where one leaves off, the other picks up. We'll talk about that as well. Iron sharpens iron. If you haven't heard that before, you need to know what that means. We have the scars to prove it. You know, 15 years of innovation, we've seen it all. We've gone from idea to proving up an idea with patents, proving it in the lab, proving it in early scale piloting, finding early commercial adoption, expanding internally, going vertical. Iron sharpens iron. You know, the concept is there's so much to do, there's so much to learn, And of course, we have multiple assets to incubate and develop into commercial reality. And so those scars are so valuable, right? Because they equip you for success. And we have a number of examples in the portfolio where those experiences, some have taken a long time, but because of those experiences, we become particularly well equipped for commercial success and knowledge to be able to capture significant commercial opportunities. And it takes time. So these lessons, I could spend an hour on this one slide, which we're not going to do, but I just want to highlight, because we'll touch on some of these examples as we talk about the technology journey itself. And the first, of course, is you have to do, and I want to emphasize, all the work, all the work. You know, it takes a long time to learn that. I remember in one of our assets, especially in the medical field, we found ourselves in a field in which we needed very special talent. We needed very special knowledge about the regulatory pathway. And of course, even the competitive barrier to entry is so significant. And so what we learned with that asset in particular, and it's proven true across the portfolio, is that when you say all the work, what you're really saying is the invention, the proving up, the early commercial adoption. And that's an extraordinary feat, especially for an entrepreneur, because each of those is unique talent sets, number one. But number two, it's very difficult. It takes a lot of money, a lot of time, and special knowledge to achieve that goal. When we say all the work, we say the hardest work. You have to do the hardest work to find your way into the commercial success. So in that asset, just to give you an example, you know, early stage, as we had the idea of product development based on our technologies, and knowing that it would have a significant impact in the medical field for health, infection control, things like that. What we discovered is that the knowledge was so special and the regulatory pathway so burdensome that we had to develop the special talent and capital base to be able to really push through. Nobody's going to pull you through. You have to push through the barrier, and that requires capital. So in that asset alone, probably about $6.5 million was invested in developing the skill, the knowledge, the product design, the third-party data. When we went through regulatory, which would have been normally about a 1.5-year process, it turned out to a little over a 3-year process, investing about almost $4 million, just getting through the first 510(k) clearance on regulatory approval. It's an astonishing accomplishment, extraordinarily difficult when you're really trying to figure out how to not, get the right people and also capitalize that endeavor. Now here's the good news. We made it through, right? But then when you get through, you have to sell it. And we're just now at that selling stage, having invested really almost 7.5 years getting through that regulatory process, product design, building out the infrastructure necessary to compete with global multinationals with all the money in the world and a strong desire to hang on to the market share. It's just an example where the process really highlights this concept that it's very difficult to find the pull from the market to generate the cash flow to get through in such a significant endeavor. Now, the other thing we learned, of course, is that the more innovative it is, the more difficult it is. So it's the paradox. You want innovation because you want competitive edge, but the more innovative, the more expensive, the more difficult to get through regulatory barriers and find early market adoption. Those early adopters are so valuable, so critical, and so yet so hard to find. So the sum of that really, it better be worth it. In BioLargo, we believe it is worth it. Why? Well, it's a high impact business. I mean, everything we do, we say to ourselves, if it's not number one, why would we do it? If it doesn't have a chance to be a technical breakthrough of significance, where really it can become a disruptor as opposed to incremental innovation, how do you finance it? How do you get the money and the staying power to get through all those barriers? It's one of the reasons our company's been able to maintain its innovation cycle for almost 15 years. And we still really are at a point where we've had success, but it's as I say, it's scratching the surface. The opportunities are so big and so significant, and we're watching our company achieve critical mass and really begin to see some of that pull from the marketplace because we've sustained ourselves for a long time. We've proven out our innovations. We've weathered the storm. We've gotten through regulatory, and we've got a little bit of critical mass now with talent that's able to sell these technologies in through the market in a significant way. I said I wasn't going to go too long on this slide, but capital formation, right? It always takes longer and more money than you think. And so our case is definitely that way. And it takes a certain amount of staying to sit back and know that the prize is worth the cost, not just capital, but personal. It's a very, very difficult challenge for really everyone. And so staying that course of innovation for 15 years, and all the while advancing, but all the while also experiencing the barrier to entry, that glass ceiling, trying to push through in a competitive market. I'm often asked, people say to me, do you have competition? I'm like, competition everywhere. You know, you focus on have incremental value solutions. We believe ours is disruptive, but there is a status quo. People are doing what they're doing. They've been doing it a long time, and that change is very hard. And so again, highlighting that difficult barrier to entry. I always say invest in your ecosystem. You know, these are just four or five principles and that we've learned from really hard lessons and a great deal of experience. And there's more, of course, but invest in your ecosystem. We invested early in our ecosystem. You know, no man is an island. You just can't make it alone. It takes a village. In our case, that represents a whole series of strategic decisions. One is, just to give you an example, we developed a research company in Canada. So our headquarters is in Westminster, California. We have an engineering group in Oak Ridge, Tennessee, light manufacturing, selling organization here. Years ago, we made a decision to invest in Canada by forming a Canadian subsidiary, recruiting a CEO, up shop at the University of Alberta in Edmonton. So you say, what? Just think about that for a minute. It's a pretty unusual approach to really take that initiative. And yet for us, it represented an extension of the history of the innovation with our founder, Ken Code. It also, so reinvesting in that ecosystem is important. It also gave us an incredible depth of resource at the University of Alberta. Now, fast forward, that was years ago. Fast forward, one of our innovations has received over 100 grants. 100 grants. You know what it takes to get 100 grants? It's so much work. And so that academic approach, sources that were garnered for that decision really put us in a favored nation position with funding capability, with research capability. At one point, as we were going through the heat of R&D side on one of our water innovations, working for us in the summer, with students training up bright minds. We've hired multiple postdocs and students working through the academic system. It gives us an incredible tool of talent and access to tools that most companies don't have. In fact, we'll show you. We did a validation project at a particle accelerator, right? Who gets access to a particle accelerator? Well, we do, because we've invested in our ecosystem. The other one I would really point out, that's a whole story unto itself. The other one I'd point out is that we've invested in our trade groups like TMA. And we're involved in a number. We're involved in 4 clusters. We're involved in 3 trade groups. We're invested in the process of establishing relationships and breadth of contact and knowledge. And the business opportunities and the connection to people and knowledge is so valuable. I just can't undersell it. Really critical. And then finally, of course, it's talent, right? When you find the right people at the right spot and the right timing, magic happens. That's what's happening with our company right now. We've managed to stay the course of innovation, proving, finding early commercial adoption, but we have a talent pool that's extraordinary. I can't remember the exact count, but it's something like 7 PhDs and 6 or 7, 10 engineers. We've got a staff of about 36 people, 27 or so employees, and then a consulting group that's with us for the long haul. And that talent pool has allowed us the ability to as we say, become a solution provider. A solution provider means that when we go in to meet with a client, you know how it starts? It's a lot different. When you make that evolution to a solution provider, we believe the commercial opportunities expand 100, not 2x, it's like 100. And that's what we're experiencing. So the concept is we have a toolkit of innovation providers solving big problems for our customers. It really is it's a very, very powerful shift and something that can't be done overnight, but I can't stress enough the importance of that strategy. So our intellectual property, of course, is the building blocks as an innovator. And the reason these are interesting is with so many assets, we've experienced the full circle, right? The full circle effect. Just to give you an example, the first innovation that we started with was a chemistry complex, iodine chemistry complex that is a platform. It's an incredible sort of discovery. KenCode started that years ago. And we've invested over a decade advancing the science of that to the point of completion, right? Completion. What does completion mean? We know what it is, how it works, how it doesn't work, what interferes, where it goes, where it doesn't go, how it combines with other materials, 4 different manufacturing techniques, an investment of data that is beyond reproach at the highest level. It's a massive investment, but what it represents is a novelty in the antimicrobial field that is a disruptor. And again, why is it a disruptor? Because it's that good. It's that good, okay? Now, look, it's easy to say that. It's hard to prove it. We have known since inception it was that good. It's taken us almost a decade to prove it. And prove it in a way, right, in a way that finds adoption at scale. And so in that technology suite, as a result of, quote, doing all the work, the hardest work is the way to think about it, doing the hardest work, it positions us for significant commercial success. So how does that translate? Odor product and VOC control product has become an arsenal of toolkit. It's delivery systems, it's manufacturing technique, it's dosimetrics, it's interference, all those things we talked about, with a precision that allows us to walk into an environmental situation and know how to deploy it successfully. Really, it's critical as the science itself. If you can't make it work, it's a science not ready to go to work in the commercial field. It takes both, and it takes people willing to do it, right? The other thing that it allowed us to do, and this is that full circle, right, through innovation, is position for partnerships. Capital required companies, just shut them down and it put the company in stall. Okay, so why is that important? Well, fast forward, right, 12, 13 years later, having invested, years and millions of dollars, we've become expert in the design and implementation of those product designs. So we entered in, just as an example, we entered into with a company that's launching a product, started in December, on the consumer side, where we're a manufacturing partner on the supply chain and a participant in the exit, and our partner is advancing and investing significant dollars in creating a significant commercial retail play. Had we not done the work, gone through all the experiences of safety, design, manufacturing, that make those products work in the long haul, we never would have been positioned to enter into and secure a relationship in which our partner is investing millions of dollars in marketing and advertising and promotion to build a brand to become a blockbuster brand. It's a significant commercial opportunity for us, and it's the fulfillment of over 10 years of work now finding its place in the marketplace in commercial success. Very similar in many respects to the medical products, which is a derivative of that intellectual property. Again, fascinating journeys, a million war stories, as you might imagine. The other is our AOS, Advanced Oxidation System. I always say some of our technologies are not rocket science. That one's rocket science. The AOS is pretty special. I'll talk about that. The AEC is a new innovation, finding rapid adoption. We're going to talk some of the detail of that. And then at the backbone of the company really is this highly skilled talent for engineering services. We'll talk about that. The concept, of course, is invent it, prove it, and partner it. Invent it, prove it, and partner it. And the proving is really interesting. It's not just a technical proof, it's a commercial validation proof. We believe that the ultimate success in a significant way requires that the company go through the invent, prove, all the way through early commercial adoption. That's an extraordinary challenge, not for the faint of heart, also not for the companies that aren't well funded. It takes real resources to do that. We believe that that maximizes the commercial opportunity for partnering. And so in the AEC is a good example. By doing, quote, all the work, we're in a position to partner with multiple channel partners in different segments of the industry, which is exactly what we're doing. So in that core group, our engineering services have 20 and 30 years of experience, okay? At a 55,000 man firm, right? So in this situation, we were doing the development contract with a 55,000 man firm because we had some technology that needed scaling up. What was missing in our portfolio, talent that had the cycle into commercial success. And so we had great, smart people, but we needed that track record of serving the commercial markets. And so we made a decision to start our engineering firm. So as the world turned, this and 18,000 people got laid. Bold decision, and we ourselves, these are really talented. Could we possibly figure out a way to bring in an entire team all at once and develop our own engineering services group with 20 and 30 years experience working at the highest level globally? And we did. It was extraordinarily expensive. I'd say it was one of the highest risk decisions we made in our journey. It also has proven to be one of the most valuable, because what it does for us is it gives us a chance to go into the marketplace with the specific talent pool that allows us to present ourselves with the knowledge and the experience equivalent to the largest engineering firm in the world. That's what we have. And as a small company, that's an extraordinary feat. Naturally, it has limitations, right? It has limitations because you have to scale it. And we're facing that scale up right now. And it's a very exciting time. It's also incredibly challenging because our opportunities are expanding really fast. So what has that done for us? Well, it's gave us talent, give us credibility. They've established, when we formed our engineering group, now just imagine this, we presented that group with three distinct jobs in one. That's a group doing three jobs. It's not one job, it's three jobs, and balance them. That's quite a challenge. For us, it was necessary. It was a way to get early adoption in commercial markets, generate some cash flow, establish credibility. As a result, we're working with Fortune 100 companies. We're also working with the United States Air Force, as mentioned on the left. Those projects not only present cash flow, of course, but they also present expanded technology access and chance to sell in our technologies into these existing relationships. It's been awesome, just awesome, and a critical component of some of our current innovation. So I want to just reframe real quick. I know I get long-winded. A lot to share. The company, air, water, and earth, science and engineering, solving big problems. That's who we are, right? Science and engineering, solving some of the biggest problems that face our planet. It's a big vision. We make life better, right? We find our little incremental spots to win, and we narrow our focus where we can find that traction to get through the evolution of proving up and find the pull from the market. That's what we've been doing for a long time. It's working. We have multiple of those pull situations now with explosive growth opportunities. So PFAS is one of those. If you don't know about PFAS, just do your internet search on your own. I'm going to give you a primer, because the byproduct of things like nonstick coatings. And these products were sold for 30 plus years by a big industry to make nonstick coatings. They were huge multi-billion-dollar wins for these corporations. They made a fortune. And the reality is they sold it everywhere. They put it in carpets and food and cosmetics and On and on we go. The problem is these fluorine compounds are called forever chemicals for a reason. Nature can't break them down. The suckers last forever. So you say, well, but they're, you know, they have low acute toxicity, right? Yeah, okay, that's fine. But if you got a part per trillion and you're putting it in every day for 30 years and it bioaccumulates, you have a real problem. You know, now we're measuring PFAS in the polar ice caps. It's in mother's breast milk. Okay, lawsuits are going on all over the world. You know, check the news. It's incredible. It's one of the top agenda items for the current Biden administration. The EPA has now segmented it, and it's heading to a RCRA designation under Superfund designation. And the cleanup projects are like massive Superfund cleanups. Okay, so about 2.5, 3 years ago, we set out on a course to develop a solution to extract PFAS from very large bodies of water and from soil. At SBI. And then we did the hardest work ourselves, right? Proving it all the way through commercial validation. We're now at a spot where this asset is now in its first commercial trials. It's taken about 2.5 years. We have an innovation that we believe is highly disruptive to the marketplace. And we're proving it through our commercial work in order to expand through partnership with channel partners across the globe. Most people estimate this at a $60 billion a year market. I'll give you an example. PFAS was detected in the parts per trillion above testing limits in Orange County, California. That's where our headquarters is. There's 67 wells that were detected with a high concentration of PFAS. When you have a high concentration of PFAS, essentially you have to turn off the well. So what does that mean? That means you have to get your water from somewhere else. Remember, California is one big desert. This big desert, okay? They need that water. And they import a lot from Northern California. So it stressed the system in a significant way, and in one of the times of great drought, right? Orange County estimates the cost to treat those 67 wells at over 1.5 billion over the life cycle of treating those wells. I had a chance to ask one of the lead engineers, you know, if you had a solution to actually clean the well, which is really even more challenging, how long is it going to take to get that PFAS out of that well? Maybe 30 years. Okay, this is not going to go away overnight. This is a 20-year, 30-year industry that's emerging based on a contaminant that took 30 years to get there. It's probably going to take 30 years to get out. It's an astonishing challenge, and we're at the center of that hurricane, as you say, the storm. So what do we do, right?
Hey, Randy, I'm sorry to interrupt, good sir. We're at about 25 minutes for your presentation, so we want to get to a Q&A here before our time
great.
out. I hate to interrupt you because you're just getting into like some really interesting stuff. So perhaps we can address this as well in the Q&A if that's okay, because PFAS is a big one.
Yeah, no problem. Why don't I wrap up real quick with like a sentence per, and we'll be done.
Excellent, very good. Thank you.
I'll do it in a minute. Yeah, sure.
Thank you.
So the PFAS solution is a device. It treats water. It has a significant value proposition. Most of 1,000 of competing technologies. Anyway, we're in the process of rolling out. It's a big business, you can imagine. Our AOS, this is the technology that's received over 100 grants, extraordinary efficiency at destroying and removing micropollutants from water. Things like estrogen that get stuck in water. Micropollutants are a big business in Europe. The United States is catching up. We're probably about 2 or 3 years ahead of the curve in America, but it's coming. These pollutants need to come out of the water. That's that particle accelerator example. Here we are going into the field. These are big systems, industrial base, focus on municipal clients. We just did a partnership with the largest privately held water company in America. We're rolling out a product. We're in commercial trials. They basically said, you make it, we'll sell it. We're very proud of this relationship, a great company. And we believe this alone can move the needle for our value proposition as well as our company. And we're going to grow around that partnership in a big way. And this is that consumer product I mentioned. It's pooph.com, pooph.com. It's a great little video. It's got a chance to be a blockbuster. Be sure to take a look. As we mentioned, we've got a lot going on. We've got a joint venture in South Korea, significant operations, and a host of talent. So there you go. Thank you very much.
Excellent. Fantastic, Dennis. I really appreciate that. And again, I hated to cut you off just as you were getting into some really fascinating aspects, especially with PFAS. And we do have some questions about that. So it's okay. What I'll do is I'll start with a question over to Randy, and we'll just kind of go back and forth if that's okay. So Randy, one of the questions that came in is how often does NASA have to calibrate or recalibrate their satellites?
Well, that's actually a question that I might not be qualified to answer, but I think that they would be looking at the data on an ongoing basis. I know that the systems that we've built for their vicarious calibration, we go out on targeted missions to acquire the data, but NASA has long-term funding in persistent observations to do this. So the satellites will fly over daily, and weather conditions permitting, I believe it's daily, I'm not actually an expert, weather conditions permitting, they would be getting measurements that they can be using for this on that same time scale. So do they actually make the adjustments that frequently? Probably not, but they're constantly collecting data to keep an eye on calibration drift.
Excellent. Thank you very much. Let me go back to Dennis with a question. Can you tell us if the units being sent to Garrett Callahan are still on schedule to be shipped in the first quarter of 2022? I'm not sure if that's a joke.
They're probably going to push into second quarter. Reality. We just finished our manufacturing validation testing. We've got our first customer lined up. We're now producing a portable pilot trailer mounted unit, which can be moved all over the country with clients. We're hoping to get that out in the next 45 to 60 days. We'll have a trial. It'll take probably about 45 days. But that project is probably about $1 million project for us. So that's a nice start with that relationship. Garrett Callahan's estimating that they'll do something like 30 to 50 installations over the 12 months that follow. So it's a nice, very nice financial and practical situation for BioLine.
Excellent.
I wish it was faster, just for the record.
Fair enough. Randy, another one for you. Was your partnership with AdaptaSense and Organic Meeting something that grew over time, or was it quick and opportunistic?
I would say a combination of quick and opportunistic and organic. And I say organic in the sense that it came from a meeting from our founder and a mutual friend of AdaptaSense's CEO at a wedding with a cocktail in hand. And then from there, it was quick and opportunistic. AdaptaSense had recently, in the last couple of years, acquired Bro Research Organization, and they are very similar to us in that they've been around for over 40 years, and had a founder who was getting ready to retire and needed new direction, new growth, and so AdaptaSense took that on, and when they met Rocky and saw us, they said, this looks very familiar, although Bro is in the software space and we're more in the hardware space. And so AdaptaSense saw that as an excellent fit to sort of get that synergy. And from that point forward, it was just a handful of months and some facilities inspections, looking at the financials, and it moved quite quickly from there.
Okay, thank you. I have a question back to Dennis. Sure. What do you mean by commercial trials for AEC? Have operations begun on site for clients, or is this occurring at BioLargo facilities?
Yeah, so we built a water lab at our facility in Oak Ridge. And so we can run essentially commercial scale pilots. Now, some of these projects on the PFAS, give me an example. If you're going to do a municipal project, you're talking about 2,000 and 3,000 gallons a minute. That's a massive pipe, okay? So the way that works is we need to demonstrate scalability in the design. And we've chosen a modular design that allows us to layer up and then scale to whatever level is required. Because at the core performance level, we're optimizing across a membrane, an electrolytic cell to migrate PFAS across the flow of water to then bind it like flypaper to a membrane adjacent to the cell. It works extraordinarily well. The reason that technology is special is it allows for selective extraction. If we can selectively extract a PFAS molecule, we avoid extracting all the other salts. If you get all the other salts, you now have a mountain of carbon laden with RCRA hazmat. That's not a good problem. I mean, that's bad. Okay. So we present such a significant value proposition. So when we say commercial scale, we're building devices that go into the field to work with the specific water of a customer. So we have a couple of big clients in the works. One is the federal government. The other is one of the largest water districts in the industry, widely considered one of the most innovative. And so what we're doing now is we're testing their water on site. We're gathering an extraordinary level of data to show its efficiency in the selective extraction and its operation capability for maintenance and service over time. You've got to remember, and I know it's hard, but these are projects that can be in the $5 and $10 million a year running for 20-year scale. These are hundreds of millions of dollars worth of projects. So nobody pulls the trigger on a flyer. And we have to prove, which we're doing quite well. And then, then it goes into a construction mode. The other thing that's fascinating is when you win one of these projects take about a year to get to scale. You know, it starts with feasibility, preliminary design, then construct, turnover, operations, and then maintenance and disposal. There's a multifaceted economic machine that comes to bear, and the scale of these are equivalent to a Superfund cleanup. Okay, it's extraordinarily significant business. Now, the good news is we're very well positioned to be a major player. And the way we think about it is we can do one, we can do two, we can do three, because we have the talent to do that, but we don't have enough manpower to do 500 of them. So we're going to partner, and we want to select our partners very carefully. And we want to do that partner selection when we're loaded for bear and ready to go to market, which is coming soon. So.
Thank you for that. Back to Randy. One of your slides, you talked about where your technology is being used, aquaculture, algae blooms, and whatnot. So what are some of the more, what are some of the stories you can come up with? Like, you know, when you use your technology, you know, what have you been able to discover, or what has surprised you? What kind of insights have you had? Do you have any stories along those lines that were interesting for you?
I think, you know, I'm going to sort of loop back to something I referenced earlier in the presentation about, you know, the most compelling, actionable use of our technology in that space was a project we did with Los Angeles Department of Water and Power. And that was a project where I got brought on to manage that project. And Los Angeles is an interesting water district in that they actually store finished water to distribute to customers. And one of their challenges is that they bring water in from the aqueduct, they treat it, they store it, and then they distribute it to the customers. But in the storage, it can be subject to algae blooms. And so they would treat it with chlorine or other disinfectants. Well, the way that they had been monitoring that previously was through a biologist would show up weekly and take a water sample and send it to a lab and determine, well, hey, you know, is there any algae? Do we need to do something about this? Well, it turns out there was two things that was problematic with that approach. One of them is that algae blooms are exponential in nature, so that they don't grow linearly, they explode. So if you take your water sample on the wrong day, and the algae bloom starts the next day, by the time you come back, you've got a green reservoir. The other problem that they were facing was that there was new research showing that the disinfection byproducts from the chlorine and other disinfectants actually were bad for people's health and additionally impacted the taste of the water. And finally, the disinfection method itself, chlorine, was very expensive. So they used to use a hammer in order to disinfect their drinking water, and they would turn on the chlorine as much as it took based on the algae bloom. And we were able to install our optical instruments in their reservoirs at two different depths. And by using a strategy with the differential absorption of different spectral wave bands, we could provide near real-time data in a daily report that showed up on their desk of when there is the slightest uptick in algae population. And so that's the kind of thing that your naked eye would not be able to see, but through the sensitivity of our instruments, you could see that there's a different ratio in the spectral bands. That would then allow the water managers to do a very, if you will, a drip treatment of the disinfectant product. And so they ended up having greater water quality, better tasting, healthier, and a significant cost savings. And so that was a great success for us. And that project has sort of gone away for a number of reasons. One is because of after 9/11, they started to restrict more access to the reservoirs and in fact cover the reservoirs so that there'd be no way to sort of throw poisons or what have you into our drinking water reservoir. And so everything's gone to a covered finished water situation. But that's sort of the most tangible application for that technology in terms of harmful algal blooms or algal blooms in general.
Yeah, that's fascinating. Thank you very much for that. I love the practical stories about how, you know, what you've talked about, what they actually lead to. We talked about this before, and it's always super invigorating to hear more stories. Back to Dennis, and then we have about 10 minutes left, but there is one question that's come in for both panelists. That is an important question. But first, Dennis, you mentioned the South Korean joint venture. Has any revenue of significance been generated at this point? And there's a follow-up question to that as well.
You know, that's a great question. We like that partnership very much. We were dealing with integrity people, very technical. The company's BKT, and we set up an office in Daegu. Daegu is one of the leading water cluster centers in the world. It's slow. COVID hit them hard. We started that joint venture right before COVID, and if you check now, you'll see that very much they're still in shutdown mode, as is most of Asia. So the COVID thing is the number one issue. In addition, however, they're also very precise. You know, these people generally think in decades, not in quarters. And so it's slow. We had a meeting. We actually just had a board meeting, had a regroup with the team. They've invested in about 30 plus trials, building data sets. They also expanded regulatory approvals through the Korean regulatory scheme. So they've done remarkable work, and they've done it on a shoestring, right? It's not a massive investment. BKT does about $250 million a year or so. They've got 20 plus years of history. They've got a very large staff, 100 plus people, and they've got a very great reputation in the market. We predict that it will be successful. It's not fast. So financially, we're a 40% non-dilutive shareholder. It's really going to be a little bit before we really make a significant amount of money, but they are also becoming expert in the area that we have been practicing for 8 years. So if you think about it that way, they're well positioned for a very nice future. I wish it was faster, but welcome to that's our journey. It takes a lot of work.
Well, like you've said before, that the hard work's been done, but this is just another thing you gotta push through, right? So
yeah. Big barriers. That's right.
Yep. I wanted to make sure to ask this question as well before our time ran out. For both panelists, it's clear you've developed critical solutions to our world's water challenges. What is standing in the way of more adopting, and how might this audience help? Randy, would you like to start?
Sure. I'd say the biggest thing, well, I guess for us, the biggest thing is, and it's one of the challenges that we touched on, is the identification of how to take the instrumentation and turn it into actionable data. And in particular, do that with minimal human handling and human processing. And I described, an application where we had success with that. So I think, to step back from that problem is to take the science and turn it into industrial application. And I think one of the things that Dennis touched on is that, sometimes you need to do all the work for that and bring it to people, and then things can move slow. And another perhaps problem that we face is that not many people, there's not many people that do what we do. So it's a niche market. And so we don't have that much exposure. And on some level, it means we don't have too many direct competitors, but it's not something that industries around the world say, oh yeah, we got to go find the people to measure the light. And so sort of broadening our exposure and just getting our instruments into different markets, different marketplaces, working with different partners is the key to that. And, and that's part of why we are part of TMA BlueTech and doing this greater outreach. We've sort of been doing a very science-intensive operation for many years, and we're trying to broaden that scope.
Okay, to you, Dennis.
So the water world is a really fascinating industry to me. It's a precious resource that's been sort of abused for a very long period of time. And as technology's advanced, our ability to measure contaminants and understand what's in that water is at a peak, and it will continue to improve, right? I mean, because technology advances. So my experience has been, it's an incredibly slow adopter. And regulators trail. And so, how do you help? Well, I think innovative clusters like TMA is really critical. That co-op sort of relationship where you get exposure, it's incredibly valuable. The other is funding resources. Canada's probably a decade ahead of the United States. I mean, they look at these precious resources as investments in people and their number one assets, which is natural resources of Canada. And so they invest in people like us. And that is, I can't even explain how valuable it is, right? There's just no way somebody could do the things that we've done without that kind of resource. But I think it's also very much a connection, a contact sport, as Ken would say. This is about relationships that are built over time that include trust, scientific trust, integrity trust. And as you establish those, it presents opportunities. One of the great stories I love is about Oriana's business, who's spent 20 years in development and is an overnight success after 20 years, right? Well, how did that happen? It happened with relationships, finding a niche market with a well-funded global player who says, holy cow, can I do something with this? And all of a sudden the world expands. And I think that's the way our business kind of works. You do this hardest work, you slug away, and then all of a sudden you're an overnight success after 15 years. And in our book, we think it's multiple because we've invested in so many. But my goodness, right? The staying power is just so difficult to overcome. So how can you help? It's as simple as, reaching out and saying, I know somebody that needs something, or, right, develop a relationship that allows for opportunity to happen. So it's a very exciting time. I think the cost of water will rise over time. I think it's an industry that's going to require additional federal and state funding that will allow for continued investment in talent. The bar needs to be raised, right, through education, critical. And you'll see that as you study the water industry, there's a significant outreach to communicate the challenges of managing this precious resource in short supply. And it's accentuated in places like California. So there's got to be a regulatory will, there's got to be a political will, there's got to be a funding capability, and the industry is starved for that kind of resource. I mean, when you can go into plants now that have been operating 100 years and they haven't changed a bit. I mean, it's not good. And, it's amazing that we've maintained such a good quality, but the truth is there's so much work to do. So I'm optimistic on water, but it's got some work to do.
Thank you for that. We have about 2 minutes left. We have lots more questions to get through. Hopefully we can power through this next one before 9 o'clock shows up. Have the two panelists discussed monitoring or treatment combinations using AOS as the treatment method when cyanobacteria and other algae blooms are causing water quality concerns?
We should do that. Oh my goodness, see? There we go. We got some support already. No, that's a great idea. And yes, I think Randy's sensing technology is incredibly valuable for getting ahead of the curve. If you can stop the algae bloom before it comes, is a lot better. Cleaning up an algae bloom is a mess. Okay, so yeah, I like that idea.
Yeah, we haven't talked, but we will.
There you go, perfect.
And that's how the audience can help.
I love it.
All right, very good. I have another question here. What do you mean by commercial trials for AEC? Have operations begun on site for clients, or is this occurring at BioLargo facilities? This would be for Dennis.
It's gonna happen on site. So the way that works is you do all the work in the lab, and then when you know you've got it locked and loaded, then you take it out to the field, and that's about to happen. So we're working on that with our big clients now, and it's almost anticlimactic. I mean, I want to be, I want to give you my perspective, because by the time you get there, you've already done it all. And so that's what we're doing. We're doing it all so that when we go into the field, the failure spots just don't happen. And so we're unique because we have a complete infrastructure to be able to manage a commercial trial with staff and talent and electricity and plumbing and installation and construction and bending metal and all the things that make it happen in the field, plus the technology, right? So anyway, that's coming soon. It's not in the field yet, but we're working on it as we speak.
Okay, it's 9 o'clock, but I did want to get one last question in, and this is back to you, Dennis. This comes from Jay from MITRE. I'm not pronouncing this correctly. Have there been no government issued regulations as to where the parts per trillion are concerned? Where does your tech fall in as far as PPT after remediation?
Good question. The regulatory scheme is moving pretty quick. Those are state issues. The Fed sets a limit. The states follow. They have a lot of freedom to do what they want. In the California market, of course, they're always the most conservative, which means the most aggressive with regulation. And often they'll set policy limits that exceed some technical capabilities or practical ROI analysis of return on investment to achieve that goal. Right? So it's like saying, look, I need it at 98% or 99%, but get me to 99.999 and the cost might double. Okay, so it's really critical people understand that. We did a work with one of the major water districts, and we proved a concept of non-detect. Non-detect means we took it to a level and non-detection capability. So non-detect is a very specific scientific term. Essentially for the layman, it means it's all out. Okay, and so that's an extraordinary feat. And that requires, as you might imagine, residence time, contact time, and energy. Okay, so the question becomes, when you have a contaminant that has very low acute toxicity, do you need to get to 99.999? And so the answer is, for the politician, they would say, oh yeah, I want it 99.999. So then you say, are you going to pay for it? Because that requires money. And so to me, it's a fascinating political, economic, social dilemma, okay? And it'll shake out right over time. You know, our engineers have been doing this for 30 years. They were one of the leading builders of dioxin remediation in North America, built a $200 million plant. And, you know, when you look back on dioxin, which was a big contaminant in the 70s and 80s, and the government was ruling this out in manufacturing, they spent a fortune to remove essentially a little lunchbox full of dioxin from the environment. And so, right, and they measure the regulatory response in some of these hazardous contaminants and by how many people die. I mean, it's an astonishing thing when you really peel the onion on how this works politically, social, political. So from our perspective, the good news is that we're presenting a highly efficient, complete elimination, quote, to a non-detect level. Non-detect level means you can't measure it, okay? So that's an extraordinary feat. So we're in the game to win, and the competition isn't scratching the surface on that. So we're pretty excited. I mean, we think we've got a significant value proposition to become a dominant player in a $60 billion market.
Yeah, that's just so exciting, Dennis. I mean, yeah.
You just got to do it. Just make it real.
Yeah.
Just make it real.
Yeah, it's fantastic. So I mean, we could talk about this for a long time. I just wanted to say to the audience, we're gonna draw this to a close. I believe each of the audience members have my email address. If you have any further questions to forward to our panelists here, sure. Dennis with BioLargo or Randy with Biospherical, you can reach out to me with those questions, and I will filter them to Randy and to Dennis. But I also wanted to thank you for joining. Thank you to our panelists. I want to inform everyone that our next BlueTech Global Connect is going to be the same time on April 21st. And the topic is going to be autonomous BlueTech taking on the dirty, dangerous, and dull in the ocean space. So you can register for that and attend the next BlueTech Global Connect, which is again, April 21st of 2022. So with that, I will bid you all adieu. Thank you so much for your participation. Really appreciate it. This is super fascinating and informative. Thank you so much.
Good job, everybody. Thanks.
Thank you.